So in order to graph this first one, we're going to start by putting our very first point right 5 and down 7. So right 5 and down 7 for that first point. Then follow the same pattern of over 1, up 1. We're going up here because it's not reflected. There's no negative in front of it. Over 2, up 4. Over 3, up 9. And remember that as I say over and up, I'm counting from the vertex, from that starting point. I'm not counting from the last point. And in this case, really you should be able to fit the over 4 and up 16, so do so. And then those are the points that I want you to be making sure you plotted accurately, but then you go ahead and draw the graph through it. We'll see how well I can do that here. Remember, it does need to be that curved shape. It's not the smoothest graph I've ever made, but you get the idea. All right. And then for this one, we go left 1, up 4 for the first point. Then since we got that negative out front, instead of going over 1, up 1, we're going to go over 1, down 1. And we're going to continue by going down instead of up each time we plot a point along the way here. And so check that you're being accurate with where you're plotting these individual points. In this case, you're only going to fit the over 4, down 16 if your graph goes down to negative 12, which I'm not necessarily expecting that it would. Then draw in your curve for your graph. Now when you draw this one in, we got that part already because we can see those points, but we know the next point would be over 4 and down 16. So what I do not want to see is that, where it looks like it would be crossing here, but we know it's not. We know that point should be down at negative 12. So as I continue to draw this, I want to keep it within that next grid line. And then we do the same thing on the other side as you draw that graph in. That's really poorly done. That's just scary. All right. Today, we're going to be taking down some notes, and we're going to be adding to your repertoire about what you can graph using what you already know about quadratics. So to start with, please add these 3 forms to your notes. So what we're going to be doing today is we're going to be adding on to your repertoire how to graph from standard form. So we're going to be looking at how to graph this. Now, right now, we don't have a way to graph it because the negative 6 and the plus 8, those do not have the normal effects that we're used to. It's not like this is moving over 6 and up 8 or anything like that. It does not mean that. It means that if we're looking at it in vertex form, but not in standard form. So we're going to need a little bit more information to go with this. So to your notes, I'd like you to add to the standard form part, to find the vertex, x equals negative b over 2a. That's a formula we're going to be coming back to over and over again. So you already have down that standard form part, the part that's grayed out, hopefully. We're adding on how to find the vertex. Make sure you've written it down correctly. X equals negative b over 2a. Every now and then somebody writes it down incorrectly, causes some problems for weeks until we finally figure out what happened. All right. With that in mind, we can now start approaching this equation and the graph of it with something concrete. So we're going to start by finding the x-coordinate of the vertex for this one. So remember that that formula that we just put down is x equals a negative b over 2a. Okay? We need to figure out what the values of these variables are. So what is the value of b in this particular equation?
6.
I hear lots of people saying 6, but it's actually not 6, it's negative 6. Since it's minus 6x, we need to keep that minus with it. So b is going to be negative 6. Okay, what about a? What's a in this case? Well, a is that number in front of x squared. There's no number written in there, so it is a 1. So in this case, a is going to equal 1. And c, by the way, is 8, but we're not going to need to know that in this problem. All right, so let's go ahead and plug that information into our little formula here. X equals a negative b is negative 6 over 2 times 1. Sometimes people start working with this and they say, wait, what do I do with the negative and the negative? Notice I just kept that negative sitting out front of the fraction, and the negative 6 is what's plugging in, so it's a negative 6 on top. I'll worry about the negatives as I have to. For the moment, though, I'm applying that negative to the fraction as a whole, and so I'm going to have to figure out what that fraction is first. So I'm going to do that negative 6 over 2 times 1. Okay, well, 2 times 1 is 2, of course, so it's going to be negative 6 divided by 2. What is negative 6 divided by 2? Negative 3. So the minus is still there. That is this minus that we had from before. Then, when I did that negative 6 over 2, I got negative 3. I'm going to go ahead and put that in parentheses so I don't see that minus negative and get confused. So x equals a negative negative 3. What does a negative negative 3 equal? A positive, because a negative times a negative, which is basically what we're doing here, is a positive. So x equals 3. So by using that little formula, we can find out what the x-coordinate of the vertex is. And if we know what the x-coordinate is, well, then we can find out what the y-coordinate is. So we should now be able to figure out what is the y-coordinate of the vertex. How? What am I going to do in order to find the y-coordinate? Yeah. Absolutely. We plug x back into the equation. So I'm now going to, in order to figure out what y is, I'm going to go y equals, and I'm going to plug my x-coordinate that I found, which was 3, into x in that original equation. So everywhere where x appears, it becomes a 3. And so we're now going to evaluate that. Remember, we have to do all exponents and multiplication before the addition and subtraction. So 3 squared gives me 9 minus 6 times 3, that's 18, plus 8. Now I can go ahead and do the addition and subtraction. So y is going to be, well, 9 minus 18 is negative 9. Negative 9 plus 8 is negative 1. All right, so our y-coordinate ends up being negative 1. We now know the coordinates of the vertex. That's going to help a lot when it comes to graphing. Now, another addition for your notes then. Right below where we find the vertex, that x equals negative b over 2a. Now add that we find y by plugging the value of x back in. We find y by plugging x back into the equation. So, having found the vertex, remember we found our vertex for this particular problem was at 3, negative 1. We can now write our equation in vertex form. That was one of the forms that you wrote down to your notes a little bit ago. So, vertex form, the general form, y equals a times x minus h squared plus v. Y, h, and v. H horizontal, v vertical. Helps you remember which way each one is going. All right, so I'm going to use the numbers I've found to write this equation. So y equals a. When we talk about a here, we're talking about the exact same a as is in the original equation. It's that number in front of the x squared. Well, in that case it was 1. I don't really have to write the 1 in though, so I can go ahead and just start my parentheses, because it's assumed, if we just have parentheses, that it's a 1 in front. It is x minus h, the x-coordinate of our vertex. It's how far we moved over. In this case, it's at 3, so it's going to be x minus 3 squared. It can be easy at first when writing these to forget the squared, but of course it has to be there, otherwise it's not a quadratic anymore. All right, and then the plus v, that's how far it's been moved up or down. In this case, our y-coordinate was negative 1, so that means it's moving down 1. So we got a minus 1. So there's our vertex form. Having written in vertex form, now do you see how we can graph it? Because you can graph it from vertex form. We just had to change the form in order to be able to do it. Before we go ahead and do that graphing, go ahead and add this to your notes. One more line for standard form. To write it in vertex form, we first find the vertex. Now let's go ahead and do the graphing. Now if you're given this problem, just graph this equation in standard form. The very first thing you want to do is you want to write it into vertex form. Now we've already done the work for that. We know our vertex form should be y equals x minus 3 squared minus 1. So when it says to graph that originally, I got to do a little bit of legwork. I got to put it in that form. Then I can go ahead and graph it. So on your own paper here, on a graphing grid, please set up the graphing grid. Write that original equation down, the standard form equation, and then go ahead and graph it. Alright, so go ahead and make that graph. In order to make this graph, we go right 3, down 1 for our very first point. It is a positive, not a negative, so we are going to be going up here. So from that point, over 1, up 1 on both sides, over 2, up 4 on both sides, over 3, up 9 on both sides, and that's all that we can fit on our graphing grid here. So then you go ahead and draw your curve through those points. Let's see how we can do this time. A little better. Not great. Wow. See, if you give me that, I'm going to tell you to erase it and redo it. Yeah. Still getting used to how to draw a curve accurately on the iPad. Because when I do it on paper, I sketch it out lightly in pencil first. Alright, so that's your graph. And so we now can go ahead and see how we can make a graph of something in standard form like this. That means one last piece to add to the notes on standard form. How to make the graph? First write it in vertex form. Add this to your notes. To practice the ideas of what we've just gone through, here is one problem. I'd like you to go ahead and do it from start to finish. That means you're going to have to find the vertex of it, then write the equation in vertex form, and then use that to graph the equation. So go ahead and do this problem. And give a few hints, a couple things you got to know here at the very start. A should equal -1 in this case because it's a negative x squared. B should equal 2 in this problem. You'll need to know that to find the vertex. So then to find the vertex, we do x equals -b over 2a. So in this problem, that's going to be x equals -2 over 2 times a -1, which is a negative, because that negative carries through. Then I do 2 divided by -2. 2 divided by -2 is a -1. And so x equals a positive 1. And then to find the y coordinate, remember we plug that back in, so y is going to equal a -1 squared plus 2 times 1 plus 7. When we do that -1 squared, we're squaring the 1 first, and then we're applying the negative. So it actually gives us -1 plus 2 plus 7, which ends up giving us 8. So our vertex then is at 1, 8, which you can then use to write the vertex form, which is y equals, the a value carries through to sit in front. So in this case, that's going to be a -1 or just negative parentheses. Then it's x minus the x coordinate of our vertex. That's going to be -1 squared. And then plus our y coordinate. So in this case, that's going to be plus 8. So there's our vertex form. And then making the graph from there should be familiar, old hat, what you're used to. Alright, so this is what your graph should come out looking like. And then this is a little bit of summary notes about that vertex form stuff. You kept 3 lines available. You're going to add this to your notes.